A couple of big announcements from you in the last week or two. Firstly, most recently, this collaboration to develop lithium manganese iron phosphate. Tell us a bit
Yep.
more about this.
Yep. So big mouthful, lithium manganese iron phosphate, better known as LMFP. It's what we believe is the future cathode. In China, LFP has really gained an advantage because of its cost competitiveness. And that's what people are trying to achieve, making EVs more widely acceptable. And how to do that, you've got to make your batteries cheaper. To do that, you need to make your cathodes cheaper. LFP's kind of reached its natural limitations. By adding manganese, you keep the cost benefits, you increase its energy density, and you have this wonderful, new product that works better in cold conditions, etc. And we see that really over the next, towards the end of this decade, LMFP is going to start replacing LFP and really put a huge demand pressure on manganese sulfate, which is our key product.
Yeah.
Um, and so the whole point of that, and maybe I'm jumping ahead, is really then just, this collaboration is using the synergies between our sulfate production and being a cathode producer.
And so, what are the real advantages of this technology?
Okay, so if you think about just our sulfate technology to begin with, you normally take the ore, put it into solution to do, the impurity removals, the processing steps. The last step is you put it into crystallization to sell it to your customer. The customer takes those crystals and puts it back into solution. So, what we see as a big advantage is we cut that whole step out. We keep the product in solution. Working with Central Southern University, these guys are really smart guys, off the scale kind of geniuses. They were involved in the beginning of the LFP development phase 10 years ago. Very entrepreneurial, very smart guys. And what we do is we end up with the patents, the technology, the IP in the process we develop in taking our solution, mixing it with lithium and iron phosphate and making an LMFP cathode. So, we get a double win. We save money and we get a much better value add product.
And just to be clear, the removal of this crystallization process, this isn't currently being done at the moment.
No, no. So, we would be the first in creating this process and simplifying the supply chain.
So, what are the next steps in terms of moving this towards potential commercialization?
Okay, so at the moment, what we're looking at is building at lab scale. That will happen over the next few weeks. Once we've developed lab scale, we've developed the process. The guys at Central Southern University have been working on this for a while and been looking for the right partner. And it was just through our connections, through our technical director in China, Mr. Zhou, that we sort of managed to put both sides of the party together, and it benefits both. So we see that there's a very fast development curve here. So we're expecting results early in Q1 next year, and then what we would look to do from there is to sort of go through a pre-qualification process in terms of our cathode material, and look to then build a facility that could produce 1 ton of cathode material a day, which would be sufficient to go through, the testing required of cathode materials for cell manufacturers.
And just as far as this technology, clearly we're talking a significant market opportunity.
Absolutely. And the benefit of this as well is, we, like as I mentioned previously, we will retain the rights, and we'll be able to take these rights internationally and overseas. And I think the beauty of it is we'll have a complete package to pick up a sulfate plant interconnected with a cathode material plant, and put that anywhere else in the world that we wish to. We obviously want to do it in China first. We see all the technology there, all the smarts are there, but we see that as a proving ground for us to then expand elsewhere.
And look, Peter, also talk me through these test work results on your electrical rotary kiln. You found some significant energy savings here.
Yeah, look, it really sort of started again from our technical team looking at existing processes and just questioning, is there a better way? A traditional rotary kiln in a manganese sulfate plant, it's a roast reduction step, so you're converting MnO2 to MnO. To do that, you heat it up to 900 odd degrees, and then it cools down back to 80 degrees to go into the next part of the process. Traditionally, all that energy is lost. Our guys have looked at it very simply and said, how can we capture that energy, use that energy to preheat the material coming in, and by doing so, then just reducing the energy demand from the whole process. And our trial has demonstrated energy savings of 70%, like so from 300 kilowatt hour per ton of feed to down to 80 to 100 kilowatt hour per ton of feed. And so, like, not only the energy saving, it's a big step in terms of more ESG compliance, two footprint, it's a win-win-win. But the thing that has really got me excited recently is just the demand from other market commodity sectors. Things like, we've had spodumene, ilmenite, rare earths, all sorts of people coming towards us and going, we have a similar process with a similar style, old traditional kiln concept. How could we look at working with you to bring in this new technology? So, I really see that as a big tick for our future plans.
And so is this where, as you mentioned in the announcement, you're talking scope for higher temperature operations?
Correct. So what we're currently doing is so our first pilot calcined kiln is designed for like 900 degrees. Spodumene, you need a higher rated kiln, somewhere between 1100 and 1300 degrees. We're going to build a kiln with slightly different materials, same concept, to be able to demonstrate that we can do it through using spodumene as well. And so, so we're going to have two model kilns that we're going to develop. And yeah, so it's very, very open to other commodities and processing routes.
Well, clearly, given your market cap, significant potential across these technologies for Firebird.
Yeah, look, every MD and CEO says, we're drastically undervalued, but I think, we have a real project, and it's a real, very significant sort of upside potential, for our stock.
Good to see you, Peter. Thanks for your time.
Cheers.